Okay, we're back and we talked about the five steps of operation for industrial boilers. We said like we start with the pre-purging or self-check and pre-purging, then lighting the pilot, proving the pilot, opening the main flame, and then normal operation, and finally post-purge. And that is all to produce steam, especially in big large boilers. Our target is to make some steam, otherwise we're not really doing hot water unless you have high capacity hot water system that's done for heating. For for the purpose of making steam, we always have to monitor our steam load in every point of the process, and steam load is measured in pressure because steam produces a lot of pressure, and it's very difficult to gauge pressure flow as it goes in the pipe without adding the pressure, because again it's in a gaseous form and gas is compressible unlike water. So the more steam we have, the more pressure and also more temperature. So this will add also to more temperature. You want to monitor the system production of the steam using pressure gauges. So along with the system, you always have steam pressure here. And as we go along, we monitor the steam, and also monitoring the pressure between two orifices or two gauges. The difference in pressure will tell you also the flow rate or the process going through one component, be it a heater or a turbine. So the difference in pressure will tell you how much work has been done in that equipment if we are working in a power plant. The on and off control. So in the past we used to monitor pressure. We used to regulate pressure using on and off, meaning we will turn on the boiler whenever we need heat and we turn off when we don't need heat, and that will cause us to have a lot of spikes. It will be alternating between back and forth, and this is how we adjusted the steam. We also had to add, for example, one or more than one boiler to create the pressure we want. So 2 psi, let's say this is going to be 20 psi, and this is 20 psi and 20 psi, and if we want 60, we'll have three of them going together, and if we want to shut one, we can shut one off, and then we have 40. And that was a way to control how much flow we have. In another hand, we also had a big boiler with a nozzle with three different nozzle or more, three or more nozzles. So we fire one or two or three based on how much fuel we want to burn in there, and that will give us how much BTU is produced in that boiler. Come with the so we can do some modulation for control systems, and that will monitor the pressure that goes inside the boiler. So we can start with one nozzle, two nozzles, or three nozzles, and that will have us ramp up our pressure level. So if this is my pressure, and if we want to go down, we can turn down the fire or up based on the pressure required. So this is more of a modulating system than just having pressure done in one setting. This is a modulating control system. These pressure controls are placed inside on the pipe. We can, if you see here, there's a cut in and cut out to turn on and off the boiler, and if we are between those two limits, the boiler will turn on and off. Will keep running, and if we have it in the low limit, probably it will lower the fire, and it will keep remaining control between the upper high and low, and it will modulate between those two limits. So there is something called single point positioning. You don't have to know all the terminology, but it's good to have an idea of what would that mean if you end up working in a power plant and if you get exposed to high pressure steam boilers. So single point is It's a modulating control strategy that uses steam pressure as your input. So this is my input signal. What is the steam coming out of the boiler? And an output signal based on the steam input to modulate the motor that turns the jack shaft to modulate the air and fuel flow. What does that mean? So if this is my boiler and this is my output and I have a pressure control here, this pressure sensor will send signal to the boiler here, the burner here, and this will modulate both fuel and air together. So one signal only, as a if you want to do the analogy between the car, if this is your speed in the car, uh, if you are using a cruise control and you put the speed, for example, on 60, the car will modulate the fuel and the fuel will modulate the air to maintain the same speed. So the same thing happening in a boiler, but this time my monitoring signal is the pressure, not the speed. We control again the fuel and air to maintain that pressure. So if we go overboard with the pressure, it will reduce the fuel to reduce the size of the fire inside. Parallel positioning, that's a different way a strategist do it and control more than one signal. Again, we still use the pressure steam as our input signal, and the output goes to a modulating system, and that system will use a variable speed motor and will change the damper size to control the air going into the boiler. So remember the same example before where we had pressure over here as our output. This signal will go to both, not only the fuel, it will go to both the fuel. Another signal will go again parallel to the air, and it will manage the ratio in the way out and control each of those components coming inside to control the fire. So we have in the single point where we have the pressure control the fuel, and the fuel is completely directly controlled, connected to the air. Here we have a signal that goes to each one of them individually. So that's the parallel position signal. Which is better? Parallel is more consistent, they say, for combustion, because we control each one based on the output by itself. And if you have the pressure output controlling the fuel and the fuel controlling the oil, we have a fixed ratio here. So based on the amount of fuel, we're gonna get some air. That ratio can be a little bit mechanically involved, and also you have a fixed ratio. So if you have to adjust that based on the air composition of oxygen, you have to go and manually adjust that control. Meanwhile, if you have different control for each one of them, that will be pre-calculated already, and based on you will send the signal to the fuel and signal to the air, and both of those two signals we have the right mixture of air and fuel inside the boiler. So again, if you want to think about it, if you look at the car carburetors in the past, you have to go and adjust the air intake based on the fuel to prevent the engine from fluttering. In newer cars, you have an oxygen sensor going to the fuel air, and you will only control the fuel, and based on the fuel combustion, you have another signal going to the air to control it, and based on the required speed. So that's a way to look at it and think about it. So parallel controls each component by itself, and a single control only the fuel, and the fuel will control the air. Metering system, we always need to take measurement. So for metering, what do? So we can control the steam using pressure, the flow rate if we have oil using flow, and that could be done by pressure, or could be by a flow meter. That will tell you how much oil is being delivered to the boiler. And we also can control metering using oxygen sensors. So we can control, so we can have continuous monitoring of the combustion coming or happening inside the boiler, and based on that we can we can determine how much air we should introduce inside the chamber to get the right amount of fuel. So if we think of the variable speed drive, that's when you can control up and down, not just by on and off. So we can change the speed of the motor based on the required input. If we look at car oxygenation as an example, I always go to the car example because it's easier to understand. So if you turn your car, if you have a car that's been adjusted to run in high altitude, for example, and you take the car to lower altitude and you turn on the engine usually will rev up, and when it revs up, it will measure the O2 out of the exhaust and the O2 in the input manifold and compare the oxidation that's happening, because our fuel is constant. The fuel properties are constant. What you can change is the air intake. So based on how much oxygen is in the input air and how much oxidation you did, you can determine the combustion efficiency of that engine by how much oxygen is left out. And based on that, we can increase or decrease the air intake. So that's how we can measure and use metering using the oxygen sensor instead of just pre-calculate the amount of oxygen that should mix with the fuel. The system communicate with each other. There is a lot of communication going on, and based on those sensors, and that's why I wanted you to do a paper on sensors to see how those signals do interact in one system. So basically, we have a programmable logic control, logic and switches, and we also have what we call the PLC. So based on that input and that signal, we can quantify and calculate how much fuel is required and how much air is required to go into the combustion chamber. So there are electrical signals. Some of them are on and off, and some of them have high and low limit signals based on milliamps. So some of them will just give you on and off, but now we can also have milliamps, so we can amplify the signal. It's not only on and off, we can get a ratio. So oxygen sensor or two sensors, they will give you a voltage or amperage depending on the amplifier that's installed to it. So based on that quantity of amperage or voltage, you can know how much you can translate that into a number, and using that number you can put it into a logic, and that logic will do an opening and closing of that signal. But in the past, like 20 years ago, we used to use a lot of pneumatic signals. To think about that, again, I go to the automatic transmission. The first automatic transmission was using pneumatic vacuums. So based on the pressure inside the air, we can know what is the RPM of the motor, and based on that we can switch gears. So the same thing happened. For the longest time we had control using pneumatics. Now we have control using milliamps and millivoltage. It's just good to have a distinction between control and how do we manage that control and have more inputs and translate that input into programmable logic control. So that what I have for a PLC, and the control that goes and the process that goes inside, general idea of the process that goes inside the control system for a industrial boiler. Next step, we will talk about gas and gas trains and what are the code requirements for gas and gas trains based on the boiler size. Thank you.